Okay. Good morning, doctor, and good morning, everyone. I'm going to present my OpenCV project, which is how to implement edge detection using OpenCV software. So for this one, I already create an image folder under my OpenCV project. So we're going to using the bare image for this project. So for this project, I'm going to import OpenCV library first and also importing NumPy library. So I'll show you the original image first. So this will be the original image. So as you can see, the image is too big. So we need to do some rescaling factor in order to get the best image output for the edge detection process output. To encounter the large image problem, I have come up with a rescaling function, which will be scaling the height and the width. And after doing the rescaling function, will be this. So I'm using a rescaling factor of 0.7. Now this image is much smaller compared to the original image, which we can use for our edge detection process. Okay, so once the image has been rescaled, I have changed the color to gray color in order for easier illustration purposes. So in this project, I have done 3 edge detection process, which is Sobel edge detection, any edge detection, and also Laplacian edge detection. So let's go on with the Sobel first. So for the Sobel, let's go with the horizontal Sobel first. Okay, so for the horizontal Sobel, I'm using OpenCV function Sobel, and I'm putting the value of x and y, which is 0 and 1, to get the horizontal lines on the image. So the image should be like this. So this image focuses on all the horizontal line. This is the horizontal Sobel image. So now let's look at the vertical Sobel. So for the vertical Sobel, same. I have just changed the value of the x and y to find out all the vertical lines. So in this image, we can see all the vertical lines is highlighted. So this is the vertical Sobel image. So when we want to see the combined Sobel, I have used the bitwise function, which is by OpenCV. So I'm using Sobel X and Sobel Y as the parameters. So this is the combined Sobel image. After using Sobel X and Y, this will be the final combined Sobel image. Okay, let's proceed to the Kenny edge detection. The next one will be Kenny. So for the Kenny edge detection, I'm using the rescale image with the parameters of 150 and 175. For this one, I'm not changing the color to gray because Kenny, the function itself, will change the image to gray color. So it will encounter the color problem. In combined Sobel and Sobel for image, I'm specifying the color because I want the image to be in gray color, which I'll change over here. For Kenny, we don't need to use the gray. We just can use the rescale image because Kenny itself can change the color from any color to gray color. For the Kenny image, it will be so this will be the Kenny image. You can see all the edges perfectly identified using Kenny. So now let's go on to the final one, which is the Laplacian. For the Laplacian, I'm using OpenCV function, Laplacian, and also NumPy function unit 8 to get the absolute value of the Laplacian image. So for this one, I'm using the gray Because Laplacian, we need to specify the color of the image in order to get the perfect coloring. This will be the Laplacian output. This is the output. And that's all for my presentation. Thank you.